Hello, this time I want to consider the question of whether a particular set of column vectors of a matrix is identical to the plane. So, to put it in other words, is every vector in R2 a linear combination of the columns of this matrix that I'm indicating just right here? So, how can we proceed? The idea is to make a translation and reduce this problem to a more familiar question. So, in other words, is the vector equation given in this fashion: a times 4, 5 plus b times 16, 15 plus c times 0, negative 15 equal to x, y, consistent for each x and y. Of course, real numbers, right? Well, the idea is that yes, this is a vector equation, but we're going to translate it to the we're going to translate the problem of consistency of a vector equation to the problem of consistency of a system of linear equations. And what is the system of linear equations involved? Well, in this case, it's something along these lines. You have 4a plus 16b plus 0c equal to x. In the second equation, 5a plus 15b minus 5c equal to y. And we ask, is this system consistent? Right? Does it have a solution? The solution may depend on x and y, of course, right? But let's do this. Let's find out. Let's make a translation. Let's create an augmented matrix, perform a row reduction, and see if we get something more manageable. So we get something along these lines: 4, 5, 16, 15, 0, negative 5, x, and y. Then from here, I want to perform a row. It's not going to be the standard Gaussian elimination process. I just take advantage of the structure of the matrix to see if we can do some elimination a little faster. So I have to row 2, I subtract row 1, and we get the following matrix: 4, 1, 16, negative 1, 0, negative 5, x, y minus x. Well, out of this, another operation, I notice that I can use this as a pivot, and I want to eliminate these 4. So I'll do it with the following. To row 1, I subtract 4 row 2. And what do we get out of that operation? Well, something that looks like this: 0, 20, 20, 5x minus 4y, 1, negative 1, negative 5, y minus x. Well, this is eliminated now. Now we can turn this into a pivot. We can turn this into a pivot by dividing the whole row number 1 by 20. So it will be something along these lines: 1 over 20 of row number 1. And you will get something like this: 0, 1, 1, followed by 1/4 of x minus 1/5 of y 1, -1, -5, y minus x. That still remains. Lastly, I want to eliminate this in order to obtain something that looks like this one with the following operation. To row number 2, I add row number 1. And now I get something that looks like this. 0, 1, 1, followed by 1/4 of x minus 1/5 of y, 1, 0, -4, 4/5 of y minus 3/4 of x. Now, time to make the translation, right? Time to recover from what we just wrote, the syntax, to the intended meaning, the system of equations, right? The consistency of the system of equations. But that roughly translates in the following fashion. It says that b, right, this b that we have here, is equal to 1/4 of x minus 1/5 of y minus c. Now, the second row is telling us that a is equal to 4/5 of y minus 3/4 of x plus 4c. Now, what is the indication now? Well, it says that if you provide me with an x and a y, I can provide you with a b and an a, and also whichever c that I want, because there's no restriction on the c, right? You can have an additional superfluous equation if you want, indicating that c is equal to c. And with this we're done, because we demonstrated the consistency of the system on any given x and y. See you next time.